This tutorial is about some common conversions in a biology lab. If you've ever traveled to a foreign country, you've probably done conversions for currency or for temperature if you're want to know the difference between Fahrenheit and Celsius. But here we're going to talk about more common things in a biology lab: volume and weight. We'll focus on some of those today. Let's look at some conversions at home that you're probably familiar with also. For example, if you have a recipe that calls for 1 pint of milk and you only have measuring cups, like 1/4 to 1 cup, you've got to figure out what a pint actually is. So the first thing you want to do is think about how much milk you need to add, and then look up in a conversion table, and there you'll see that 1 pint actually equals 2 cups. So for your recipe where it calls for 1 pint of milk, you're going to be adding 2 cups of milk. Another type of conversion might occur if you're planning a trip to Spain. Let's say your charter airline only allows you to take 19 kilograms. All right, but your scale at home only measures in pounds. So how do you make that conversion so you know what to weigh out? Well, in a lookup conversion table, you'd find that 1 kilogram is equal to 2.2 pounds. You can set that up as a ratio, and I've drawn that here. 2.2 pounds is to 1 kilogram as X, the unknown, is to 19 kilograms. And if you solve for that, you'll see that X is equal to 19 kilograms times 2.2 pounds, and that's 41.8 pounds. And remember, you do that by multiplying both sides of your equation by 19 kilograms. You can do that in math, and you can drop out the 19 on both sides because one is in the numerator and one is in the denominator, and that's how you end up with this equation. The kilograms, of course, drop out, and that's why you're left with pounds. We'll look at some conversions in medicine because these are similar to what you'll use in the laboratory. So in this example, we have a 168-pound man who needs a vaccine. And the vaccine that you have comes at a concentration of 12 mg per ml, and you need to administer 12 milligrams per 50 kilograms of body weight. Now the question is, if you need to give this patient a shot, what volume should you use of that vaccine? The first thing we need to do is convert his weight into kilograms, because then your units will be compatible with the vaccine. So to convert, we're going to first look up in a table, and this is a constant. 1 pound is 0.45 kilograms. Now you can set that up as a ratio. 0.45 is to 1 as X, your unknown, is to 168. You can multiply both sides by 168, and in doing that you eliminate that from this side and you add 168 over here. The pounds will be eliminated, and that's why you're left with, actually you can eliminate the pounds here, 0.45 times 168, and your conversion is 75.6 kilograms. Now, how many milligrams of vaccine do you need for a 75.6 kilogram man? So again, we're going to set up a similar kind of ratio. X milligrams, which is our target we're looking for, is to 75.6, as 12 milligrams is to 50. That was what we were given. So we're going to multiply both sides by 75.6, so we will drop that out on this side, and we have 75.6 times 12. I'm going to kind of cheat and use this number up here, and that's 907 divided by 50, and we are left with 18.1 milligrams. Now our stock is at 12 mg per ml, milligrams per milliliter, so now we are able to figure out volume. So we're going to do a similar type of situation, a ratio. X is to 18 milligrams as 1 mil is to 12 milligrams, and our final volume that we need to administer is 1.5 mils. Let's look at ratios and percent solutions. So when we talk about a ratio, let's start with 1%. What does that mean? Well, 1% means grams per 100 mLs. That's just the definition of it. The way I like to remember that, a very kind of simplistic mnemonic device, is to say if you had a 1%, I rearrange that percent sign to 100, and I can remember that it means 1 over 100 because the line in the percent becomes 1 and the 2 zeros get written right there. So I have 100. And that way I can remember what a 1% means. It's 1 gram per 100 mLs. Now we can also look at that more specifically. We can write 1% as 1 to 100 then. It also means 1 gram per 100 mLs, as I just mentioned. We can write that in other ways, and this is where our conversions come in. 1 gram is 1,000 milligrams, so we can write it as 1,000 milligrams per 100 mLs. And that simplifies to 10 milligrams per 1 ml. Now let's change that percentage a little bit. Let's go up to 2%. What does that mean? Well, it actually means 2 in 100, but we can simplify 2 in 100 to 1 to 50. Let's write it, however, as the originally intended way. 2% means 2 grams per 100 mLs, and that means 2,000 milligrams per 100 mLs. And again, we can simplify that to 20 milligrams per 100 mLs. And let me reiterate the relationship between these two. 2 over 100 is the same as 1 over 50. Well, let's change the ratio again. So we're looking at a 0.5%. What does that mean? That's 1 in 200 or 0.5 in 100. And here's it showing it that way. 0.5 grams per 100 mLs is the same as saying 500 milligrams per 100 mLs, and we can simplify that to 5 milligrams per 100 mLs. And of course, we've simply cut this percent in half, and notice that we've only changed this from 10 to 5 milligrams, so that's changing it by half. So the numbers all match up. If we go to 0.1%, that's 1 in 1,000, because we've gone down a factor of 10. That's 0.1 gram per 100 mLs, 100 milligrams per 100 mLs, and that simplifies to a 1 mg per ml solution. A very common solution that you'll see in a lot of laboratories. Then the last one is 0.02%. That's actually a 1 to 5,000. So notice we've gone down by 5-fold here. That can be written as 0.02 grams, and that can be converted to 20 milligrams per 100 mLs, or 0.2 mgs per mil when we reduce it. And now we can convert that one further unit, and 0.2 milligrams is the same as saying 200 micrograms per mil. So we can get that down to 200 micrograms per 1 ml.